4.3, polynomial division, the remainder theorem and the factor theorem. So our objectives here is perform long division with polynomials and determine whether one polynomial is a factor of another. Use synthetic division to divide a polynomial by x minus c. Use the remainder theorem to find the function value of f of c. Use the factor theorem to determine whether x minus c is a factor. Division and factors. When we divide one polynomial by another, we obtain a quotient and a remainder. Okay, so what is this saying? It's saying that we're going to take our divisor, which is also called our denominator, and we're going to divide it into our dividend, which is also called our numerator. And it's going to give me a quotient. So what I multiply the divisor by is going to be by the quotient. And our end result, after finding the difference, will give me my remainder. So let's solve for this. So this here is going to be my divisor. This here is also another divisor. They want us to check both these points. We want to see if x plus 1 is a factor and x minus 3 is a factor. So let's find out. So we're going to divide to determine. So another way of seeing this could be written like this, divided by that number. It could be written like this. There's multiple ways to write our division. But remember, how we solve is how we read it. So it says this polynomial function is divided by the x plus 1. So let's plug it in long division and solve. So I'm going to take x plus 1, put it on the outside because it's denominator. Also, when we set up our long division, let me clean this up a little bit. When we set up our long division, we want to make sure there are no missing terms. We want to make sure it's written in descending order. So power of 3, 2, 0, or 1 and 0. Okay, so good. So it's written in there. We're not missing any powers. If the x squared was missing here, we'd have to put a 0 in its place, but it's perfect. It's not missing nothing. So let's put it over here. All right, so now let's solve. So what we do is we say, okay, x times what will get me x cubed? Well, I know x squared will do it. So x squared times x is x cubed. X squared times positive 1 is positive x squared. Now, we got to find the difference. So I'm going to subtract. And when I subtract, this goes to 0, that's what we wanted. And now I got negative 2x squared minus x squared. That gives me a negative 3x squared. Bring down this positive 5x. So next we say, okay, x times what will get me close to a negative 3x squared? Well, that's going to be a negative 3x. Negative 3x times x is a negative 3x squared. Negative 3x times positive 1 gives me a negative 3x. Again, we're going to find the difference. So that means we change this to positive because we're taking the negative. We're going to subtract. So it changes the signs. This goes to 0. This leaves me with 8x. Let's bring down this negative 4. Now I say, okay, x times what gets me 8x? Well, I know 8, a positive 8. Positive 8 times 8x is 8x. 8 times 1 is positive 8. Now find the difference. So I'm going to plug in the negative. Negative here and negative here. This goes to 0. Negative 4 minus 8 is a negative 12. So my quotient here, that's my quotient. Here's my remainder. And you can also write your answer as x squared minus 3x plus 8 minus that 12 over x plus 1. I put the negative that's on this 12 out front. Sometimes you may see it be plus the negative 12 over it. So you may see that. Just watch how it's asked for in the directions. And here you go. It said, so that's +1. Let's go back and check our math because it's showing that they came up with a remainder of 0, which is easy to do. So let's check our math again. Did I write it down right? X cubed minus 2x squared plus 5x minus 4. Okay, I said x times x squared gave me x cubed. Good. They went to 0. X squared times 1 gave me a positive x squared. Subtract the 2x gives me a negative 3x squared. So let's look right quick. Sorry about that. Let's zoom back out. And let's go here to this next slide. So what did they do different? So I said x squared. Yeah, that's correct. They gave us a negative. And they said, and they subtracted. Oh, so here we go. There's a typo here, guys. It should have been subtracted here, which that should have been -3. Okay, so they have a typo here. It is very easy to do. So I'm going to do the x minus 3. So guys, if y'all are reading these PowerPoints or any of the notes and it looks like something might not be right, just reach out to me. Typos are easy to do. All right, so here we go. They changed this up. They put a plus sign here when their original was minus. So I'm going to go back to the original because that's what we're supposed to be using. So let's do that. Our original equation said minus, so let's stick with it. Now I'm going to say x times what gets me x cubed? Well, we know x squared. So x squared times x cubed, or excuse me, x squared times x is x cubed. X squared times -3 is a -3x squared. Find the difference. When I find the difference, means we're going to subtract. So that gives me 0 here, and then -2x squared plus 3x squared is just x squared. Let's bring down the -5x. Now say x times what gets me close to x squared. I know a positive x. Positive x times x is x squared. Positive x times -3 is a -3x. Let's find the difference. So we're going to subtract, change the sign. This goes to 0. -5 x plus 3x is a -2x. Let's bring down the -6. Now we say x times what gives me -2x. We're going to say -2. -2 times x is -2x. -2 times -3 is a +6. And let's subtract. And change the sign. So now I'm left with a remainder of -12. Gave us the same thing. But they said they changed this, which changed to, it should have came out as a remainder of 0 is why they did that. All right, so moving on. When we divide a polynomial p of x by a divisor d of x, a polynomial q of x. So what is that? Okay, so p of x is the name of the function and it's going to be my dividend, which is my numerator. Okay, this little d of x is my divisor, which is my denominator. The q of x is my quotient. And the r of x is my remainder. Sorry, this is right here. Remainder quotient. Oh, left the I out. Okay. So, whenever we're trying to check our work, we want to see if the dividend is equal to the divisor times the quotient plus the remainder. If it's true, then we did our math work. Another one, it says if a number C is substituted for x in the polynomial functions, f of x then results of f of c is the remainder, that would be obtained by dividing f of x by x minus c. So now we get this right here. Okay. So now this is synthetic division. To set it up, we have the polynomial divided by this one first. We make sure it's in descending order. It is, check. Next, is it missing any terms? Yeah, it's missing the x to the first power, which we don't want the 1 on it, right? It's missing right here. So as you notice, they put 0 here. 2, we take our denominator, our divisor. We take it and we say, okay, x plus 3 equals what? 0. Let's solve for it. And that's where they came up with this -3 right here inside this backwards L. And now, what do? We bring our first down. We bring it down and then we say, okay, this number times this number gives me, whoops, a -3, gives me -6. So we put it right here. And we say, okay, 7 plus that -6 gives me +1. And then we say, okay, -3 times that +1 gives me -3. Okay, now we say 0 plus that -3 gives me -3. Now we say, okay, -3 times -3 gives me +9. Now we say -5 plus 9 gives me +4. So this is my remainder. So now I got my quotient. Now we started with x cubed. That means this went down 1. So now it's 2x squared. And they put a negative here in the answer. And as you notice here, there's no negative here. So 2x squared plus, and in the place of this 1, it's going to be 1 times x minus that 3. And with the remainder of 4. So we could go as far as saying that plus 4 over x plus 3. So just make sure and read it how it wants you to write it. This is my quotient, and then +4 is my remainder. This was showing you how to do another one. 1, you make sure it's in descending order. 2, you see if you're missing any, and you are missing x cubed. So this is x to the 4th, x cubed, x squared, x, and then this is the constant term, okay? So then that means we go down 1, and then we have our constant, and we have our remainder. Okay, so remember, always bring the first one down. And what they did is they took the coefficient off these terms, right? The coefficient on x to the 4th is 1. Coefficient on x squared is -26. Well, what happened to x cubed? Well, there's no x cubed showing, so we put 0 in its place. The x here, 11, this actually should have been +11 here. So that would change everything up here. This here is saying g of 5. That means in the place of x, we're going to put 5. We want to see if it is a 0. If our remainder is 0, then yes, it is a 0. But there's a typo here. They put, they said there was no x value, and there was. So that would change everything. So now I have 11 minus 5, which would have gave me +6. 5 times +6 would have gave me 30, and then that would have added up. So we would not have had a remainder of 0. So I wanted to go over with you right quick. Another way of checking. Let's go back to this one. When we said x plus 3 is equal to x equals -3, if I was to took my function, everywhere I saw x plugged in what I said, and it gives me the 0, then I can answer the question immediately by saying that. But remember, it may ask you, what is the quotient? What is the remainder? So that's just letting you know right off the bat if it is a real 0. So for a polynomial of f of x, if f of c equals 0, then x minus c is a factor of f of x. So let's solve that for it. So it said that we have x cubed minus x squared, 3x squared minus 6x plus 8. So this is my x cubed. We got positive 1 coefficient. Here's my x squared. We got a negative 3 coefficient. Here's my x, negative 6 coefficient. And 8 is the constant term. They said that when x minus 1, okay, so what is this telling me? Since we are working in f of c theorem, we're checking it, then it basically says x minus c, we're plugging in c. What is c? It said it's negative 1, so let's plug in negative 1 here. Bring down this 1, then we say negative 1 times 1, which is negative 1. Let's add negative 3 plus negative 1 gives me negative 4. Negative 1 times negative 4 is positive 4. Negative 6 plus 4 is negative 2. Then negative 1 times negative 2 is positive 2. 8 plus 2 is 10. That's my remainder. So this says, what about x plus 1? Can we prove it's not a remainder? We got to make sure that we have our constants correct here. Bring down the 1. 1 times 1 is 1. Ah, and they put negative 1 here. It should have been adding. So that was a typo there, but this is correct. And then positive 1 times negative 2. Negative 6 plus negative 2 is negative 8. 1 times negative 8 is negative 8. 8 minus 8 is 0. So yes, I'm going to say it is 1. So the notation here is going to be x minus 1 times that quotient. What is the quotient here? Remember, it went down a degree. If it started out x cubed, then that became x squared. X squared times 1 is x squared. Then I have negative 2x minus 8. Okay. So what I could do now is factor this down, right? And then we'll have have it all in factored form, and then we can find the zeros. So what is x squared minus 2x minus 8? This sign here tells me that we're going to have a difference. So my x squared here has a positive 1 coefficient, and it's a quadratic, so we can factor like this. All right. So basically saying ax squared plus or minus bx plus or minus c. We're taking a times c, which is, in this case here, 1 times 8. That what? This says subtract. The sign on c tells us if we add or subtract. It says subtract to get b. And b is negative 2. So what is the product of 8? 8 is 2 times 4, or 1 times 8. I need one of them to subtract to give me negative 2. So I'm going to go with 2 and 4. And we need it to be a negative 2, so the 4 gets a negative sign. So here we go. Check. This is how we got the whole thing factored form. Now what we're going to do is take each part, set it equal to 0. So I got x minus 1 equals 0. X minus 4 equals 0, and x plus 2 equals 0, and solves by adding the 1. X equals 1 by adding the 4. X equals 4 by subtracting the 2. X equals negative 2. So now I have the solutions of the equations are negative 2, 1, and 4.